All right, so we're working on number 4 on page 3. Okay. The problem gives that there's 75 grams of O2. So that's where immediately we're going to start. And we're going to multiply to something to convert to, looks like what the question is asking for, it's asking for how many moles of CO2 will form if we had 75 grams of O2. So we're going to say equals, and then we're going to leave a blank space and put moles of O2. Oh, CO2, my apologies. Okay. So what we want to do is we want to convert this, because it's a gram value, into how many moles of O2 that would be. Why? Because here we're going to use this balanced equation to convert from moles of O2 to how many moles of CO2 we would make. This is all in moles. So for instance, we can kind of see this recipe says, or this chemical equation says for every 2 moles of C4H10, if we mix that with 13 moles of this O2 chemical, we make 8 moles of this CO2 chemical and 10 moles of this H2O chemical. This gives us our ratios to compare to, like the ratios of chemical values to compare to. So for every 13 moles of O2 chemical, you can create, and the other guy in question is CO2, you can create 8 moles of the CO2 chemical, okay? 13 to 8. So let's say if we had 26 moles of O2, which is twice the amount of O2 we have here, guess how much CO2 we would make according to this ratio of 13 to 8. 13 mole, if we had 26 moles of O2, which is twice the amount of, here we see 13, that would mean we would create 16 moles of CO2, which is twice the amount of moles here. We want to know how many moles of O2 we have. We don't have that yet. We can't use this information until we convert this into moles of CO or of O2. But what we do have is 75 grams of O2. What we're going to need is the molar mass of O2, which is conveniently supplied here. Okay, normally you would have to use a periodic table to solve for this molar mass. What this says right here, this is the value right here. What this basically says is for every 1 mole of O2, that's 32 grams of O2. You could also look at it, this ratio or conversion factor, like this. The 1 mole of O2 is now at the top, and 32 grams of O2 goes on the bottom. The question is, which version do we need, this one or this one, to multiply to this to get moles of O2? We need this version. So let's multiply this times 1 mole of O2 on the top with 32 grams of O2 on the bottom. Now, why did we choose this version? The reason why we chose this version is because we have the gram value in the denominator. What's going to happen is if you multiply this with also the units of grams of O2, we multiply it by this conversion factor where the units of grams of O2 are on the bottom, these will cancel out. We want that. We want our answer, or not our final answer, but this answer at least of this conversion to be in moles of O2. No grams of O2 should be anywhere in the units. The reason why this cancels out is it's like in algebra when you multiply something like 9 times 2 over 9, the 9's will end up canceling out because of the way it's written. It's a whole number here, times it by a fraction with the 9 in the bottom. The reason being is if I did multiply this out, that'd be 9 times 2 divided by 9, and the 9's cancel out. So over here, you could treat that the same way with the units. If grams of O2 is here, times it by a ratio or a fraction or conversion factor where the grams of O2 is on the bottom, they will cancel out. Okay, if I did just this conversion, which is 75.0 times 1, and I divided that by 32, the answer would be 2.3 moles of O2. But that's not what this question is asking for, is it? They're asking for moles of CO2 formed. So what we're going to do is, we know that if we calculated this, this would give me 2.3 moles of O2. Then we would multiply that to the conversion factor with O2 and CO2 to get moles of CO2. I'm getting a little bit ahead of myself, okay? But here are my options. Let's erase this to make room for the two possible conversion factors I could use. What does that mean? Sorry. So we're going from O2 to CO2. So let's look at those two numbers again in this chemical equation, which all of these two, 13, 8, and 10 coefficients, they're all in moles, okay? So I have, in comparison, 13 moles of O2 make 8 moles of CO2. I could also write that conversion factor or ratio as this. 8 moles of CO2 go on the top, and the 13 moles of O2 go on the bottom. Can you guess which version I'm going to need to use to multiply to this to get the final answer? This one or this one? I'm going to tell you right now, it's going to be this version. Times 8 moles of CO2 over 13 moles of O2. The reason why is my leftover answer from this conversion was moles of O2. Well, we're going to convert that into moles of CO2. That's the unit that I want. So I have to put this in order where moles of O2 will be on the bottom. Because if I multiply this times this ratio with moles of O2 on the bottom, the units will cancel out because the units are exactly the same. Moles of O2 times moles of O2 on the bottom here. They will cancel out, leaving us with moles of CO2 as the only remaining unit that we should have left when I multiply out all these numbers, okay? And divide the bottom numbers, which is good. That's what we want. We want moles of CO2 at the very end. Okay, your last step now is to put this on a calculator. So the key is you take this number and you multiply it to the top numbers first. 75 times 1 times 8. 75 times 1 times 8. Whatever that is, I'm going to divide that by 32 and 13. You know what? I could put that all in one entry in the calculator, like this. After 75 times 1 times 8, I could put in the divided sign, and I could put in this first number we're dividing by, 32. The last number that you need to divide by is 13. So in my calculator, I'm going to put divided by 13. My final answer is 1.44, and the unit will be moles of CO2. 1.44, or just 1.4, that would have been acceptable, moles of CO2. That is your final answer.